All right, I am recording. All right, thank you so much, everyone, for your time and attention. It is an honor and a privilege to share our research and information with you. My name is Michael Academia. I'm a Master of Science candidate at William & Mary, and my advisor is Dr. Brian Watts, who is the director for the Center for Conservation Biology. And our project is about how food limitation inhibited the reproductive performance of ospreys in the lower Chesapeake Bay. Now, in this presentation, I'll cover the protocol with some time allotted in the end for some questions and answers. So please feel free to type some of the questions in the chat box, or at the end, when I stop recording, please feel free to unmute yourself, raise your hand, and ask a question. I'm excited to share this photo because this was taken from one of our trail cameras at the end of the season. Here is a photo of myself and my advisor coming in. And I promise I'm not reading a book. I'm taking some notes here, but this is our lab and this is our field. This is our work. All right, some context, some background information on why we're doing this research, and it's about overfishing and localized depletion of fish. This is an illustration from the Food and Agricultural Organization depicting where the trend is going. On the x-axis, we have years. On the y-axis, we have the proportion, the percentage. So the fish stocks represented here in orange are the stocks that are overfished and unsustainable, and it is growing. The fish stocks represented in this bluish teal color are the fish stocks that are fished at maximum sustainable yield, and it is decreasing. And the proportion of fish stocks represented by this white line are the fish stocks that are underfished, and that is also decreasing. So there is mounting concern with the state of our fisheries. And there's been a paradigm shift from single species maximum sustainable yield models into a model that considers trophic interactions. And that is called ecosystem-based fisheries management. And this is a holistic approach that considers trophic interactions and aims to promote the health and resilience of the ecosystem. For example, to the left, we have an illustration from the Pew Charitable Trust. Now, the forage fish here is usually the primary target for our fisheries. And with maximum sustainable yield models, it would be a single species type of targeting. Now, with ecosystem-based fisheries management, we consider the trophic cascade from the bottom to the top, and we pay particular attention to the top predators, such as our large fish, marine mammals, and of course, our birds. Now, recently, the Atlantic States Marine Fisheries Commission, the governing body that manages fisheries along the Atlantic coast, formally adopted the use of ecological reference points. And these are predators that can serve as reference points, which can allow management to practice informed decisions to develop harvest targets and to assess the role of forage fish for upper trophic levels. The theory behind that is that if we leave enough forage fish in the water, it would be enough to sustain our larger fish, marine mammals, and our bird populations, such as ospreys. Bird populations may serve as an early warning system for changes in fish populations that have ecosystem implications. So like the proverbial canary in the coal mine, birds can warn us of dangerous levels of overfishing and the state of our aquatic environments. The fishery that has the focus on the Atlantic coast and Chesapeake Bay is Atlantic menhaden, and is considered by some the most important fish in the bay. It is a type of herring that has a high energy content, high in lipids. And this has been the largest fishery by volume along the Atlantic coast. And the fishery began in the 1800s and peaked around the 1950s and the 1960s. And there were about 20 factories along the Atlantic coast. But after the peak, the factories north of Chesapeake Bay shut down due to fish scarcity, except for one. There's one factory that remains and has been a source of contention and conflict. Now, one of the major issues is the type of fishing methods. We become extremely efficient at extracting this resource. This is called purse seining. We also use really great technologically advanced ships and also spotter planes that can view all the fish and literally just gobble it all up. It is worth big business, about $6 billion a year. There's lots of political lobbyists involved with this fishery as well. And the menhaden is reduced into fish oil, fertilizer, fish meal, and also for bait. Now, according to the Atlantic States Marine Fisheries Commission, Atlantic menhaden is considered a single stock, and along the Atlantic coast, it is not considered overfished, and that overfishing is not occurring. However, it may be inappropriate to use a broad scale estimation on a spatially explicit area that is critical to Chesapeake Bay, to the sustainability of this fishery. So another major problem is that Chesapeake Bay serves as a critical nursing ground. Menhaden spawn along the coast, and the juveniles, the young, head into bays, into estuaries to grow, to get large, and they recruit into the adult population. But within Chesapeake Bay, as soon as they recruit into the adult population, they are susceptible to overfishing. So to the left, we have an illustration from the Pew Charitable Trust depicting the major ecological service that menhaden provide. They're a forage fish, a food base for our iconic species such as striped bass, whales, bald eagles, and of course, ospreys. And we can't forget about ecotourism and recreational fishing. And recreational fishing targets usually striped bass, and they've seen a decrease in catch with striped bass. So here we have tragedy of commons. Anytime we have a commonwealth, there is an inherent issue of overexploitation. Now, according to the Atlantic States Marine Fisheries Commission, localized depletion is defined as a reduction in the menhaden population density below the level of abundance that is sufficient to maintain its basic ecological, economic, and social cultural functions. And we have been seeing signs of this, and there's not much scientific evidence until now, and we are building that scientific evidence. So the model that the Atlantic States Marine Fisheries Commission is using was developed by one of my professors at Cal Poly, Humboldt, and his name is Dr. Andre Bucheister, and they developed this very complicated model with ecological reference points. And they have established some ecological reference points that are sensitive to the overfishing of menhaden. So if you look at the figure on the x-axis, we have fishing mortality, or F, and this is fishing mortality from fishing pressure. On the y-axis, we have the biomass index. So represented in this black line is the menhaden biomass. Now, the sensitive ecological reference points are striped bass and also the nearshore piscivorous birds, as indicated with this orange dotted line. If the menhaden biomass decreases, so too does striped bass and nearshore piscivorous birds. And included in the nearshore piscivorous birds are ospreys. And their reproductive success is inextricably linked to menhaden. They're a migratory raptor, and they time their breeding period to the availability of fish, to the availability of menhaden. They're the only raptor that can plunge dive. They're an obligate piscivore, which means that they depend on fish 99+% of the time. And being plunge divers, they are more sensitive to the perturbations of fish availability, more so than your pursuit divers, such as loons, cormorants, or grebes. They are highly visible, highly charismatic. They bring their prey out of the water and they put them on display for everyone to see. So they make ideal subjects for research. They exhibit strong nest fidelity. They come back to the same nest year after year. They are central place foragers. So they have a nest and they will always bring back the fish to the nest, and they habituate to humans. They have also been substantiated as ecotoxicological sentinel species, measuring toxins in the environment, especially during the DDT era. And their utility as ecological reference points have not yet been fully explored. So the opportunity to do more research is now, to evolve the data, to evolve the models that we are using. So the Center for Conservation Biology has a long legacy of graduate students studying the relationship between menhaden and ospreys. In the 1970s, we have Christopher Stinson. In the 80s, we have Peter McLean. And in the early 2000s, we have Andrew Glass and myself in 2021, 2022. So we have about 47 years of experience studying the relationship between ospreys and menhaden. So the objective of this study was to determine whether the osprey population within the lower Chesapeake Bay was experiencing food limitation during the 2021 breeding season. Now, a clear barrier to assess this relationship was that we did not have this key vital information here, this predictor variable, and that would be the prey density, the menhaden density, the number of fish per area. And we would have used this predictor variable for the response variable, the mean prey consumed. And then we could assess the functional relationship. But because we did not have this data available to us, a food manipulative experiment in the wild was required, which led to our main research question. Would ospreys experience higher rates of nest success and productivity if they receive food supplementation? And we hypothesized that ospreys experience food limitation due to the lack of fish availability, and we predicted that treatment increased productivity and nest success. So this is a map of the Chesapeake Bay in its entirety, and represented in the red dots are the osprey nests. And it would just not be feasible to apply that food experiment throughout the whole bay. So we focused our efforts in a bellwether, an adjudicator of the relationship between menhaden and osprey, and that is Mobjack Bay, located here in the lower Chesapeake Bay. Let's focus in on Mobjack Bay, which consists of the Ware, North, and East Rivers, and also Davis Creek. Now, in our initial boat survey, there were about 100 nests located in this area, but we had to carefully determine which nests were suitable to do research. The tides, we needed boat access, we needed to deliver the food. And once we determined that, we used a random sampling generator to categorize our treatment groups. So for the treatment nests, it's indicated here in the blue circles, and for the control group, the control nests represented here in the red triangles. So the treatment protocols were initiated once eggs hatched until the young were about 6 weeks. And we sourced menhaden from a local fishing supply company that was prepared and delivered via a telescopic delivery device. And this device here was actually engineered and handcrafted by my father. So thank you, Dad, for making this. And we delivered about 2.4 fish, or about 472 grams every 3.55 days on average until the young reached 6 weeks. And nests within the control group were observed concurrently with the food addition group, and the young were inspected via mirror pole. But before we get into that mirror pole, I wanted to show some evidence that the trail cameras captured of the fish deliveries. Here are some of the nestlings and this careful placement of the fish. And it's really important to inspect the nest with the mirror pole before dropping the fish over, because we could have inadvertently dropped the fish on some little baby osprey chicks, as indicated here. Here's a little bobblehead, which is very difficult to do on a boat with high winds and all that jazz. Okay, so the mirror pole, here I am. This was also engineered and handcrafted by my father, so thank you very much, Dad. And we are beginning to have some publicity, some media coverage. William McKeever is a writer, filmmaker, and we brought him and his film crew to check up on some nests. And they're doing a documentary on menhaden and the Chesapeake Bay and ospreys. And that should be released during the Sundance Film Festival, and that may happen in a month or two. But I wanted to share some of this video that we captured.
What do you say, Michael?
Nothing.
Empty.
Empty.
Here comes the pair.
And that was an empty nest. This is a video of a nest that has 3 nestlings. I'm sorry, it might be a little difficult to see there, but they are very well camouflaged. And as you can see, you know, the stripes on the back, they look like sticks. All right. So you can hear the nestlings, and also that was mother circling overhead with a warning call. We also attached trail cameras to some nests. Some of the nests were on old duck lines, such as this. We attached the trail camera to some conduit and attached the conduit into some of the nesting substrate. And you can see how large this nest is. It's been used, you know, time and time again. And here to the right, we have some osprey nestlings with some color on them because we needed to know who was the youngest, who was the oldest. So red went to the eldest, the blue to the middle, and green to the youngest. And with the trail cameras, it was really important to get the photos because we needed to get some important information about the fish species. And there, we recorded about 20,000 photos, so it took a long time to process. And I'm really thankful. Thank you, Dr. Jenny Rand, for introducing me to ImageJ. It just helped me so much because from a known length, such as the talon or bill, we can get an estimation of the fish length. And from the fish length, we can get biomass and also energy content. So biomass, we used each fish. We used a species-specific length to mass equation from published literature. With energy content, we converted biomass to energy using published species-specific energy density values. And for the unknown fishes, we used length mass equations and energy density from a representative species of the taxonomic group. Some key items I need to define because these are some of our response variables. Nest success. A nest is considered successful when a pair raise at least 1 young to the minimal acceptable age. Fledglings. We define the number of fledglings as the number of young in the nest that reach the 80% of first flight age criterion. That's about 6 to 7 weeks. This is a major important one. This is productivity, which is the number of fledglings per active nest. For our statistical analysis, the data was not normally distributed, non-homogeneous, non-parametric, so we needed to use the appropriate statistical tools. We used Pearson's chi-squared analysis to test the relationship between the treatment types and nest success. We used generalized linear models to compare the productivity, the number of young hatched, and brood reduction between the treatment groups, and also to test the influence of provisioning on natural and supplementation, on provisioning, on productivity. And we use generalized linear mixed models to test the association of the influence of food addition on total provisioning, natural and supplemented. And we used trusty RStudio, we used the MAST and the GLMM TMD packages and validated our analyses with the Dharma package. All right, we're now on the results. So for the food addition group, 13 of the 6 nests succeeded at 81%. Only 3 nests failed during the first 1.38 weeks, and the productivity rate was 1.3 young per active nest. Compared to the control group, only 5 of the 50 nests succeeded at 33%. 10 nests failed during the first 2 weeks. The first 2 weeks is usually the critical period in which nestling mortality is experienced. And the productivity rate was 0.47 young per active nest. And you can see the condition of a nestling in the control group. There is no crop and emaciation. So this is a mosaic plot representing the two-way contingency table used for the chi-squared analysis. Blue represents the successfulness, red represents the failedness. On the x-axis, we have the treatment type. To the left, we have food addition. To the right, we have the control group. On the y-axis, we have the status of nest success. Red failed, blue successful. So on the left, the food addition group, 13 of the nests succeeded and 5 failed. For the control group, 3 nests succeeded and 10 nests failed. And according to our chi-squared test statistic, this was significant? So this answers our main research question. Yes, the food addition group did experience this success. So the biological meaning is that they had enough food to provision their young. Now, this represents the comparison of the productivity. So to the right, we have the food addition group. To the left, we have the control group, the y-axis, the productivity rate. Now, these are violet box plots, and these wavy lines represent the density of the data. So the thicker it is, the more data density there is. Now, for the control group, productivity rate was mostly around 0, whereas with the food addition group, it was above 0, nearing 1. Also, I'm sorry, the box plots also represent the median values. And according to our analysis, our model, this was significant. There was a significant difference between the productivity rate of the food addition and the control group. So again, this answers the main research question. There was a significant difference between the productivity rate between the treatment types. Again, for the food addition group, the parents did have enough food to provision their young. Now, it was really important to account for some bias, and a source of that bias would be clutch size. Here we have clutch size on the y-axis, and you can see that density data was around 2 for both treatment types, and you can see that there are some outliers here. But according to our tests, this passed, which means that there were no significant differences between the food and control nests. So there is equal footing here. We accounted for the bias. Now, another source of bias could have been the number of young hatched, also here on the y-axis being represented here. Now, with the data density, you can see that with the control group, there was some of the data was spread out, but most of it was around 2. And also for the food addition group, the number of young hatched was about 2, but also with 3. Now we ran our tests, and this passed. This failed, so this was not significant, meaning that there were no significant differences of the number of young hatched between the treatment types. Again, accounting for bias, equal footing, good to go. Now, brood reduction could have been another parameter used to test food limitation. So here's brood reduction on the y-axis, and this is just nestling mortality during the breeding season. For the control group, you can see data density around 1 or 2 losses. And for the food addition group, mostly centered around 1. And according to our test, there were no significant differences in brood reduction between the control group and the food addition group. And we believe that this discrepancy was due to the treatment protocol. Maybe it wasn't frequent enough or strong enough to produce a significant difference. Okay, so we also wanted to test the influence of the number of fish added on the total provisioning rate, natural and supplemented. And according to our tests, yes, food addition did have an influence on total provisioning. Likewise, we wanted to test if there was an association and influence of the fish addition in terms of biomass in grams per day on the total biomass. And I know for you stats gurus out there, you will be looking at this and see that there is some zero inflation here. And I did use the GLM TMB package, and it can account for this, and it was significant. And similarly, we did this for the energy content in terms of kilocalories per day, energy content total, natural, and supplemented. And yes, this did have a strong association and influence on the total energy content. All right, let's take a quick departure from all of the stats and graphs and figures and numbers into some really cool things that the trail cameras captured. I wanted to remind you that the control group had 4 trail cameras attached to them, while the food addition group had 7. And it just happened that the amounts were not equal due to the random sampling generator and also with the accessibility of the attaching the cameras to the substrate. Okay, so here is a capture of an osprey delivering to menhaden. There were a couple of times we went on in the field and we witnessed an osprey delivering to menhaden, which is super cool. They're schooling fish, so it's appropriate that they would catch, more than one at a time sometimes. Next is gizzard shad, and I was surprised that they were delivering this fish because this is more like brackish water, so they were probably heading more towards inland, and the size of this gizzard shad is really impressive. This is also another popular fish that was being brought to the nest, and this is spot with that very clear sign right there, that spot near the head, spot near the head. Now, this was a peculiar fish. This was a unique fish that was delivered to the nest. This is Atlantic needlefish, and go ospreys for the size of this Atlantic needlefish. Here's the head here, but then you can also see the Atlantic needlefish here. The length of this fish was almost the size of the nest. Very impressive. Another interesting catch was Spanish mackerel. So this was probably more towards the salinity, higher salinity areas here, and also just really nice sizes. The iconic species, this is red drum. You can tell by the coloration and also the dot on the caudal peduncle. And the most iconic fish in the bay, striped bass. I expected that ospreys would be delivering more of this fish, but it was really low. It was like only 2%. So to summarize, the diet composition consisted of menhaden at 39%, Atlantic menhaden or fish from the herring family at 10.3%. This is croaker at 5.8%, gizzard shad at 5.7%, and also spot at 5%. Now, sometimes it was really difficult to differentiate croaker between spot. I couldn't see the spot sometimes. And also, they have a first and second dorsal. But if you look at the caudal fins, spot has an emergent truncated fin, whereas with the croaker, they have a truncated convex fin. And I also had help from someone at VIM, Sarah Muffelman. Thank you so much for helping me identify some of the fish. Okay, so we need to close the loop with our data analysis. I could have had this question in the introduction, but we would have long have forgotten. And that question is this: how much added fish in terms of biomass and energy content would be needed for ospreys to produce 1.15 young per active nest? Now, let me talk about this metric here, 1.15 young per active nest. Again, for Chesapeake Bay, it's context dependent. We need to hit this number here in order to have a break-even minimum productivity rate so that the production would offset mortality. Okay, so according to our stats analysis, we did another model. On the x-axis, we have the added average fish in terms of biomass per day, and we wanted to test the association, the influence on the productivity, the number of young per active nest. This red horizontal dotted line represents that threshold, that minimum break-even point, and this vertical line represents the added average fish biomass needed per day per nest in order to reach that productivity rate, and that is 63.4 grams. And according to our model, this was significant. Similarly, we wanted to test the association, the influence of the added average fish energy in terms of kilocalories per day on the productivity rate. Here's the horizontal line representing that productivity rate and the vertical line representing that energy requirement. And that energy requirement is 121 kilocalories per day per nest on average. And according to our statistical analysis, that was good to go. Yes, significant. All right, we're now in the discussion and the conservation threshold for ospreys. So again, remember that everything is context dependent, especially for Chesapeake Bay. And this was from the big hitters, the renowned scientists who've studied ospreys for a long time, Dr. Rob Beauregard, Dr. Alan Poole, and this represents the osprey populations in southern New England and Long Island, New York. And here are a bunch of lines that represent the osprey populations in these locations. Now, this productivity rate here, this was 0.8, which was used as the threshold needed for these populations. And the most important thing to pay attention here is during the 60s and 70s. Here, below that threshold, at around 0.5, represents the osprey populations that are experiencing crashes. Now, the productivity rate was around 0.5. Interestingly, the productivity rate experienced by a control group was 0.47. So this is actually below the productivity rate when osprey populations were crashing during the DDT era. So we need to study this. This is a cause for alarm. And context dependency, right? For Chesapeake Bay, the productivity needed for that minimum break-even point is 1.15 young per active nest. For our food addition group, we barely met that. It was at 1.13. Okay. So the estimated world osprey population is 100,000. Here at Chesapeake Bay, we can boast we have the world's largest breeding population of ospreys. And this is something that we should be proud of, something that we should protect. This is the world's stronghold, so it deserves our attention. But at 0.47, a productivity rate that is very low along the main stem, we should be concerned. This was a photo taken by Dr. Brian Watts of a hungry osprey nestling. Just want to remind you of this model that we use for the added average fish biomass needed. Now this, we once again close the loop for analysis, and this is what we wanted to submit to harvest policy. Another question, what is the average biomass threshold needed per day per nest for ospreys in Chesapeake Bay? And we determined that number is 208 grams, or about half a pound per day per nest during the osprey breeding season, needed for them to reach that minimum break-even point. Another picture taken of mother feeding the youngest chick. Reminder of the kilocalories energy content. So again, close the loop with that analysis for harvest policy. What are we going to be giving to fisheries management? What is the what is the total energy threshold needed per day per nest for ospreys in Chesapeake Bay? And that number is 347.6 kilocalories per day per nest. So in conclusion, ospreys are sensitive indicators or ecological reference points of menhaden availability. And the best metric that we can use is the productivity rate at 1.15 young per active nest. So to continue our studies and research, if they are reaching this productivity rate, they'll be breaking even. Of course, there are other metrics to use. Here, this photo is the comparison of the body condition of the eldest chick with the middle chick. And you can see with the eldest, right, you can see a full crop, great body condition, whereas with the middle chick, there is no crop and very poor body condition. Again, this is a sign of food limitation. Ospreys, raptors will ensure that they are productive. So they have to, if they don't have enough food, they have to ensure that at least one will succeed. Now, according to the Atlantic States Marine Fisheries Commission, Amendment 3 of the Interstate Fishery Management Plan, ecological reference points are nascent in their use. This is just the beginning. And ERPs are described as a method to assess the status of menhaden, not only with regard to the sustainability of human harvests, but also with regard to their interaction with predators and the status of other prey species. So ospreys make an excellent exemplary ecological reference point. There are so many people that I need to thank. Dr. Brian Watts, my committee, other professors, and my colleagues. Also, my funders, the International Osprey Foundation, the Virginia Society of Ornithology, the Coastal Virginia Wildlife Observatory, and the Williamsburg Bird Club. Some literature cited. And here's some photos of me holding some baby ospreys. Once you have a little osprey in your hand, it's pretty life-changing. And I want to continue my work for a very long time. All right, thank you so much, everyone. I'm going to open up the floor now to your comments or questions. I am going to stop recording, so feel free to put your videos on